Hi guys, the last section for DMA 65. We're going to look at solving quadratic equations using the quadratic formula. If you remember on the last page of that of our last set of notes in section 8.4, I was talking about there were a couple on that last page that you weren't able to do because you didn't have the tools yet, and really what we needed was the quadratic equation. So that's what we'll be looking at today. So here in example 1, it says a local model rocket club launches a rocket that follows the path given by the equation, and here's our equation: h equals negative 16t squared plus 170t plus 5. H standing for height, and t is time in seconds. And h is the height of that rocket, of course. In part A, they say the phrase, when the rocket will hit the ground, contains the word when. So in our case here, it's asking, well, does when indicate that we're trying to determine the height of the rocket or the time? And hopefully, this is a very straightforward. It just means, okay, we're looking for the time, okay? Scooting on down into part B, it says, well, when the rocket hits the ground, what is the value of the height? Okay, so if the rocket hits the ground, what is its height? Its height would equal 0. Hopefully that makes sense for you. Negative 16t squared plus 170t plus 5. And we will we'll talk more about solving this kind in here in just a few minutes. Part C says, well, what kind of equation have we represented here? Definitely can't be linear, right? You're raised to the second power, so it can't be linear. Rational has a division of polynomials. We don't have that. Radical has a square root. We don't have that. We are definitely quadratic here. In part D, it says, well, what two methods have we learned prior to this section for solving quadratic equations? And up until this point, we've predominantly relied on factoring. So you've been able to factor using guess and check or bottoms-up method, and that's been able to solve quadratics for us, as well as the square root property. However, as I have been alluding to, you're not always able to factor a quadratic. You're not always able to factor quadratic, and then sometimes you're not able to just use that nice square root property. So when you aren't able to use those two methods, then you've got to have some other way to solve the equation, and that's where the quadratic formula comes into play. So, oops. In order to use the quadratic formula, you need your quadratic to be in descending order according to your x's. So here you have ax squared plus bx plus c. A, b, and c are just numbers, and it always needs to be equal to 0. So everything needs to be all on one side, equal to 0, and go in descending order: x squared, x, and then your number. Okay. If we flip it on over then to the next page, quadratic formula is given to you up at the top, okay? So your solutions are found using this formula. It's read as negative b. Actually, you're going to hear me say, I'm going to say opposite b. So opposite b plus or minus square root b squared minus 4ac all over 2a. You want to go ahead and commit this formula to memory, because for those of you, which I'm assuming if you're in this class, you're taking pre-calculus. So, and then many of you may be planning to go to calculus on from there. You have got to have this formula in your back pocket, know it frontwards, backwards, and so anyway, you need to go ahead and get that formula in your toolbox. So, like I said, quadratic formula: opposite b plus or minus square root b squared minus 4ac all over 2a. Okay, where again, a, b, and c are just the numbers in front of your variables in the quadratic formula, quadratic equation itself. So the steps to solving a quadratic equation, like I said, if needed, you need to get everything all on the right side equal to 0. Make sure it's in descending order, and your leading term cannot be 0. If your leading term was 0, then you don't have a quadratic, and there's no need to use the quadratic formula. I always say, recognize what are your values for a, b, and c. Substitute those values into the quadratic equation itself. Then you're going to have to simplify and that sort of thing. You'll end up with 2 answers and simplify. Okay, so let's just go ahead and jump into one so you can kind of see it all play out. So actually here in example 2, I'm going to do A and B with you, and then I'll let you try C. I'm actually going to do B first. Okay, so it is from the start, it is not in descending order. So what I'm going to do then, or it's not equal to 0, excuse me. It is in descending order, but it's not equal to 0. So the first thing I need to do is get it equal to 0. So let me pull that 12 over, subtract 12 from both sides. So now I have x squared minus 4x minus 12 equals 0. So now I'm ready to use the quadratic formula. Let me go ahead and identify my A, B, and C. So get a different color here. Remember, this is A, B, and C. So we're saying then that A is a positive 1, B is negative 4, and C is negative 12. So you're taking any minus signs that you see, you're taking those as negatives. Okay, so there's your A, B, and C. Now, like I said, you're ready for your quadratic formula. So it says opposite B. So the opposite of negative 4, that's going to be positive 4, plus or minus square root B squared. So take that negative 4, square it, minus 4 times A, which is 1, times C, which is negative 12, all over 2A, so 2 times 1. keep cleaning up. So you have 4 plus or minus underneath that square root. Negative 4 squared gives us a positive 16. If you rely on your calculator to give you that 16, you have to use the parentheses. Back here, negative 4 times 1 gives me negative 4, and then negative 4 times negative 12 gives me positive 48. And then all that's divided by 2 on the bottom. One more step. I have a couple more steps sitting. Clean that up in there. So 16 plus 48 will give me 64. All divided by 2. Now we can set this up into, there's 2 answers. And actually, let's do even before I do our 2 answers. We know the square root of 64. This one's nice. When you go ahead and take the square root, if you're able to take the square root of what's underneath the square root, then that means this problem actually could have been factored from the beginning. And I picked this one to do first just so that you could get nice numbers, because typically when you use the quadratic formula, you aren't able to factor, and so therefore you're not going to get nice numbers. Now, so our answer here, we have 4 plus or minus 8 all over 2. So you should be able to give me 2 distinct answers. So what that means is that you have 4 plus 8 divided by 2, and you have 4 minus 8 divided by 2. Well, of course, 4 plus 8 is 12 divided by 2, which is 6. So that's one answer. 4 minus 8, negative 4 divided by 2, and that gives me negative 2. So 6 and negative 2 are our final answers. So now, if we go back up and look at part A, I'm using my, first thing I need to do again, I need to get it equal to 0, so pull that 18 over. X squared minus 6x plus 6x minus 18 equals 0. Identify your A, B, and C. So remember A, B, and C. So again, it's just telling me A is positive 1, B is positive 6, C is negative 18. All right, so now you're ready for your formula. Formula says opposite B, so the opposite of positive 6, negative 6, plus or minus square root B squared, so 6 squared, minus 4 times A times C, all over 2A, so 2 times 1. Okay, now from here, let's clean up that square root. So negative 6 plus or minus the square root 36, negative 4 times negative 18, positive 72, all divided by 2. And that's going to give me negative 6 plus or minus 36 plus 72 will give us 108, all divided by 2. All right, we'll bring that over here. So now 108 can be reduced a little bit further. So negative 6 plus or minus, remember when you're thinking about reducing your square roots like we've done previously in this chapter, you think about perfect squares that will divide evenly into 108. Remember your perfect square list: 4, 9, 16, 25, 36, 7 squared 49. You just, keep going. But 36 will go into 108. 36 times 3. Remember, you look for the highest number of those perfect squares that will divide evenly into the number underneath the radical here. So now we know the square root of 36 is 6, so it comes outside the house. 3 stays inside, all divided by 2. At this point, all of the numbers outside the house have a 2 in common, so I need to reduce. 2 divided by 2 is 1. That's smaller. 6 divided by 2 is 3. 6 divided by 2 is 3. So then I have -3 plus or minus 3 square root of 3. Those are your two answers in what we refer to as exact form. And then if we want to get approximations, then you would put in your calculator -3 plus the square root of 3, and you would get approximately 2.20. And then you would put in your calculator -3 minus the square root of 3, and you get approximately a -8.20. Okay, and then, like I said, these two are referred to as your approximate solutions. Like I said, most cases when you use the quadratic formula, you've already exhausted that, hey, I can't factor it, so therefore I go to the quadratic formula, and you end up with answers that are not they're not pretty. Okay, you're going to have decimal answers. Okay. All right, I'm going to let you try example C down there. I'm going to flip it on over. Again, it's a good opportunity. Pause the video and you try some. I'm going to look at E and F with you. Those are the two that have just a little bit of something. Actually, E doesn't have really too much different going on with it. I just thought I'd do another example, and then F has a little bit something different. Okay, so looking at letter E. In letter E, first thing again, I need to get it equal to 0, so I'm going to pull that 1 over. So do the opposite, subtract 1 from both sides. So I have 16x squared minus 16x minus 1 equals 0. So you've got your A, your B, and your C. You're ready for your quadratic formula. It says opposite B, so your B right now is -16, so the opposite of that would be +16 plus or minus square root B squared, so take that -16 and square it, minus 4 times A times C all over 2A. So then that gives me 16 plus or minus the square root. -16 squared will give you 256. And then back here, -4 times 16 will give you -64, times -1 will give me a +64, all divided by 32 on the bottom. 16 plus or minus then the square root of adding those two together, you get 320, all divided by 32. Draw myself a line here to keep me. All right, so now we want to break down 320. So 320, you just start, like I said, dividing by those perfect squares. 64 happens to be the highest, so I'd have 16 plus or minus the square root. 64 times 5 is 320. Then I know that the square root of 64 is 8, so it comes outside the house. At this point, 8, 16, and 32 all have something in common, so therefore I can reduce. If all three of these numbers did not have something in common, I couldn't reduce. Okay, but in this case, all three have something in common, I can reduce. And actually 8 goes into all of them, so I can divide them all by 8. 16 divided by 8, of course, gives me 2. 8 divided by 8 is going to give me 1. 32 divided by 8 is going to give me 4. So I'm going to end up here then with 2 plus or minus the square root of 5 all over 4. So again, that would be your exact solution. So this is your exact. To get your approximates, you're going to have two answers. Again, you would put in your calculator 2 plus the square root of 5. And if you're going to do it all at one time, then you need to use parentheses. Me personally, I just type in 2 plus the square root of 5, hit enter, and then divide by 4. You should get approximately 1.06. That would be one of the answers. And then 2 minus the square root of 5, all divided by 4. Again, if you're going to type it all in at one time, you have to use parentheses. If not, you can just type in the top, hit enter, and then divide by 4. And that is going to give you approximately a negative 0.06. So those would be, again, here's your exact, and my two approximates, 1.06 and negative 0.06. Okay. And then let's look at a special case down here in letter F. So here in letter F, you can see I'm already all on one side in descending order equal to 0. So I can already go ahead here and identify my A, B, and C. I can see, okay, A is 5, B is negative 2, C is 3. If I go to my quadratic formula, it says opposite B. So since B is negative 2, opposite of that is going to be positive 2 plus or minus square root B squared. Take that negative 2 and square it. Minus 4 times A, which is 5, times C, which is 3, all over 2A, 2 times 5. All right, just work across here. So now I have 2 plus or minus the square root of 4 minus, let's see, 4 times 5 is 20, 20 times 3 is 60, all divided by 10 on the bottom. And that's going to give me 2 plus or minus the square root of a negative 56, all divided by 10. At this point, we're going to be able to stop because hopefully you remember what we've been talking about. I can't take the square root of a negative number. So we stop here at this point. In pre-calculus, you're going to go further. But at this point, we're going to say we don't have any real solutions. And so therefore, we can't go any further. We will have what are referred to as imaginary solutions, but that's a topic for, like I've been saying, pre-calculus. Okay. All right, so let's do one more together, and then I think you should be in good shape with this section. All right, so here in example 3, it says the students in the club from our introductory example want to know when the rocket is going to hit the ground. Okay, so and they tell us here if there's more than one answer, which answer makes sense. So they've kind of got it set up here. You know, the rocket's going to hit the ground, so you're looking at the height here equal to 0. So plus 170t plus 5 equal to 0. Let me just erase a little mark there. Okay, and then I'm ready for my quadratic formula. Just identify here for you. Here's my A, B, and C. All right, so opposite B, so I have a negative 170 plus or minus square root B squared. So 170 squared minus 4 times A times C, all over 2A, so 2 times negative 16. Okay, so it's a big number here, putting this in our calculator. So now I have a negative 170 plus or minus the square root. 170 squared will give you 28,900. And then from here, negative 4 times negative 16 will give you positive 64, and 64 times 5 will give you a positive 320. All divided by a negative 32. All right, if we clean that up, we get a negative 170 plus or minus square root of 29,220. Divided by negative 32. Then from here, you know, since it doesn't tell me like I have to have it in any particular form. So I mean, I know that this number here could be reduced in some way, but it just wants to know when the rocket's going to hit the ground. It wants to know this time. So my two time scenarios are that I have negative 170 plus the square root of 29,220 divided by negative 32. Again, if you can do it all in your calculator at one time, you'd need parentheses up top. Me personally, I just do the top, hit enter, then divide by negative 32. If you do that scenario, you get approximately a negative 0.03 seconds. The other scenario, negative 170 minus the square root of the 29,220 divided by negative 32. And that would give you approximately 10.65 seconds. So you're talking about time here. Can we have a negative time? And hopefully you would agree, no, we can't have negative time. Only this nearly 11-second mark makes sense. So basically, it's 10.65 seconds. So basically in 11 seconds, that's when their rocket's going to hit the ground. That's the only one that makes sense here. Okay. If you flip it over, I don't think there's anything too different in that last one. I'll let you try it. T is time in seconds after the water leaves the nozzle. H is the height of the water droplet, and they want to know how long does it take the droplet to land in the harbor. So once it lands in the harbor, then at that point, its height is equal to 0. So again, you're basically repeating what I just did in that previous example. You're setting this height equal to 0, and I've got it fully worked out for you online, so I think you'll be in good shape. But if you have questions, feel free to let me know. Thanks a lot. Bye.